Hello again. We are going to move on to some rules of differentiation based on the basic derivative that we found in the last lesson. So this is lesson 12.4, and let's get started. From the last lesson, we learned that in general, if I have the function y equals x to the n, then the derivative of that is going to be dy dx equals n times x to the n minus 1. And we talked about how this applies to negative exponents because so that the derivative of x to the negative 1 would be negative 1 times x to the negative 2. It also applies to fractional exponents, so the derivative of x to the 1/3 would be 1/3 times x to the negative 2/3. So let's move on to some more ways that we can use that rule. We can actually add and subtract derivatives that look like that. So if I have a function that's x to the third plus x to the fifth, I can take the derivatives of each of those separately and add those derivatives together. So the derivative of x to the third plus x to the fifth would be 3x squared plus 5x to the fourth. I can also multiply by a constant. So if some function in that form is being multiplied by, let's say, 7, then I take the derivative of that function and multiply it by 7. So the derivative of 7x cubed would be, instead of 3x squared, it would be 21x squared, so multiplied by 7. Here's what you can't do, even though you may be tempted. You can't multiply derivatives, and all we have to do is look at a counterexample to see why that's not going to work. So if I had a function that was x cubed times x to the fourth, well, I know that that's x to the seventh, but if I tried to take the derivatives of x to the third and x to the fourth separately and multiply those together, I would not get the derivative of x to the seventh. So I really can't have the same function with different derivatives. So you see, if I take the derivative of x cubed, I get 3x squared. If I take the derivative of x to the fourth, I get 4x cubed. But if I take the derivative of x to the 7, I get 7x to the 6. So very different functions. What you should actually do in that case is actually multiply the x cubed times the x fourth and get x to the 7th and take the derivative of that. Don't take the derivatives separately and multiply them together. Your answer will be wrong. We can't divide them either for the exact same reason. If I had x to the 9th divided by x to the 3rd, then that's the same thing as x to the 6th. So again, if I try and take the derivatives separately and divide them, I'm going to get 9x to the 8 divided by 3x squared, and that's not actually what the derivative should be. The derivative should be 6x to the 5th. So again, what you need to do is you need to divide the functions first before you take the derivative and simplify that function. All right, so here's some more examples. The derivative of 9x cubed minus 13x squared would be 27x squared minus 26x. The derivative of 2x to the 1.3 plus 18 times x to the negative 2, I'm just following the same rules, would be 2.6 times x to the 0.3 minus 36 times x to the negative 3. The derivative of 7 times x to the pi plus 8 times x to the negative 3/4 is 7 pi times x to the pi minus 1 minus 6 times x to the negative 7/4. Okay, and even more examples. If functions look like they've been multiplied or divided, then you need to do that first. And that's what I was saying before. You have to simplify the function first if it's got multiplication or division in it. So if I've got x squared times 14x squared minus 10x to the 7, I can't take the derivatives of those separately and then multiply them later. I have to actually expand it out first and get 14x to the 4th minus 10x to the 9. Now I can take the derivative of that, which is 56x to the 3rd minus 90x to the 8. Okay, and similarly, if I wanted to take the derivative of 10x to the 5th minus 12x cubed all over 2x squared, I would not take the derivatives separately and then divide them. I would actually need to simplify that first, which is 5x to the 3rd minus 6x, and now I can take the derivative and get 15x squared minus 6. So those are some rules that you can use. You can add, you can subtract, you can multiply by a constant, but you can't multiply derivatives and you can't divide derivatives. So if you have any questions, please let me know and I will see you tomorrow.